Hello everyone, I am Mrs. Rushali Chaudhary, lecturer in Praveen Patil Polytechnic Bhinder. Today I am going to explain the topic water treatment, which is included in the syllabus of applied chemistry. Water treatment. Why water treatment is required? Because whatever the water obtained from the nature is not always suitable for industrial as well as the drinking purpose. Where we are required the water in the industry, we require the water for boilers, thermal power plants, constructions, manufacturing process. Without water, life is not possible. Water which is used for the drinking purpose is called as potable water. That water must be satisfied with some characteristics. What are their characteristics? It should be a clear, colorless, odorless. It must be pleasant in a taste. The pH of water must be between 6.5 and 8.5. Slightly alkaline water is acceptable. It should be free from the microorganisms. Turbidity of water should not be more than 5 NTU. NTU means nephelometric turbidity units. Dissolve solids in a water not more than 500 ppm. ppm means parts per million. If this characteristic is satisfied, then we will say that given water is suitable for drinking purpose. How we will achieve these characteristics? For that, we are going to perform purification of water. The purification process involves screening, sedimentation, coagulation, filtration, sterilization, aeration, demineralization. The process is selected on the basis of impurities. If large amount of impurities like leaves, wooden branches are present in water, water will pass through the screens. Suspended impurities like clay, water sedimentation process is used. Fine suspended matters are separated by sedimentation with a coagulation. Colloidal matters and microorganisms like fungi. It is removed by coagulation and filtration. Biological impurities like pathogens, germs, bacteria removed by sterilization process. Dissolve impurities like gases, carbon dioxide, ammonia. These gases are added in water due to the pollutions. And salts like bicarbonate, chlorides of magnesium and calcium are removed by aeration and demineralization. First process we are going to learn is a sedimentation. Sedimentation is a physical water treatment process. In this, using gravity, we are removing suspended solid particles from the water. Solid particles entrained by the turbulence of moving water may be removed naturally by sedimentation in the still water of lakes and oceans. This is the sedimentation process. Here we will observe that water is flowing from higher level towards the lower level. As water is moving, the particles will settle down and only water will move. Next process is called as coagulation. Solid particles are mostly removed by the sedimentation by settling followed by the filtration. The small particles which are not removed efficiently by sedimentation because they are too slowly settled down and it is also passing through the filters. So how we are going to remove out? We are going to clump it together or coagulate together to form a large molecules. That process is called as coagulation. In a coagulation, we are adding chemicals such as alum, which produces positive charges to neutralize negative charges on the particles. Then the particles can stick together, forming large particles, which are more easily removed. In a coagulation process, addition of chemicals involved, followed by rapid mixing of dissolved chemicals, and then distribute it throughout the water. Example of coagulant are ferric chloride, FeCl3, FeSO4, ammonium sulfate, Al2SO4, also called as alum. Here we will observe how the coagulation processes take place. In the first diagram, you will observe all impurities are scattered everywhere. It is spread everywhere. When we are adding external chemicals like a coagulant, this coagulant get trapped impurity together. They will form big lump, big mass. As the mass is formed, it is heavier and that mass is going to settle down at the bottom of tank. Coagulation followed by filtration. Filtration is a process of removing insoluble, colloidal and bacterial impurities by passing through a bed of proper sized material. Example of filters: gravity sand filter and pressure filter. Here we will observe the gravity sand filter. In this process we are using different layer which is having different sand size as well as the gravel size. The bottom layer is the gravel drainage layer, then after followed by the coarse sand, after that sand plus carbon source is there, followed by the loamy sand. When the water is passed from upward towards the downward, all particles impurities stick to the sand and we are getting the free impure then we are getting pure water. After filtration, only chances of microorganism or the bacteria present in the water, that is removed by the sterilization process. The process of destroying disease producing microorganism is called as disinfection or sterilization. Sterilization is achieved by boiling, chlorination, ozonization, aeration and ultraviolet rays. Physical disinfection, that is the boiling. Boiling kills bacterial cells, but some viruses, spores, protozoa survive after boiling also. Boiling volatilizes organic compounds. Boiling is an effective method for small batches of water during water emergencies. Boiling is prohibitively expensive for large quantities of water. Therefore, municipality is not supply or use sterilization process of boiling. Municipality is using chemical disinfection method. What is the chemical disinfection? We are going to add some chemicals in water to kill the bacteria. Chlorination is cheap, effective and harmless method. Chlorine is added in form of gas, bleaching powder and chloramine. Hypochlorous acid and hypochlorite ions form in a solution which are strong oxidant and which kills microorganisms. Chlorination. When chlorine dissolves in water, it forms hypochlorous acid and hydrochloric acid. Hypochlorous acid is unstable. It is converted into the hydrochloric acid and nascent oxygen. Nascent oxygen react with bacteria and kills bacteria. They are penetrate the bacterial external coating. Disadvantages of chlorination. It produces bad taste and odor. Drinking chlorine contaminated water and in a swimming pool, it increases the risk of respiratory problems such as asthma, particularly in children. It increases risk of cancer. It increases skin irritation. Next process of sterilization is ozonation. Ozone O3 is an effective harmless disinfection method, but it is expensive, therefore less popular than chlorine. Ozone is a strong oxidant that produces nascent oxygen which react with organic and inorganic molecules in water to kill microorganisms. Whatever the topic here we completed, you have to appear for one small MCQ test on this. Passing is 50%. Open the link below to appear for exam. All the best. Thank you so much.